did I do here? Oh. Okay, so as I was saying, we've concluded regression and now we're moving into classification. What does that mean? It basically means that before in regression, we were predicting real valued numbers. Like we were predicting like the price of a house, right? So 250,000 or temperature. That was a good example, right? If it's 0 degrees Celsius, that's 32 degrees Fahrenheit. We were predicting 32 or 33 or 34. That's a regression problem. Now we're moving into classification problems, but it's going to be very similar. Like the architectures, everything that you've learned, especially in PyTorch, it's like 80% of that we're still going to use. We're just going to tweak it now to make it for classification problems, right? And we're going to start tackling problems that are much more complex. So today I'm just going to start with the iris dataset, which is the classic Fisher's iris. But I'll do that today. And then after that, we're going to start looking at the famous image data sets like MNIST and CIFAR-10, right? And as we start looking at images, for classification, we're going to try to predict, if it's a digit like 7 or a 3, then we're going to predict if it's a car or a bus or a bird or something like that. And of course, it leads into images. And so that's going to take us to a new algorithm, which is the convolutional neural network. So our goal will be to build one from scratch in PyTorch, okay? And that's kind of the introduction of one of the advanced deep learning algorithms that we're going to cover in the class. And as I said, from there, we're going to build on what we learn in regression, apply it to classification by doing some tweaks, and then adding more advanced things like convolutional layers, etc. Okay? So that's kind of where we're going now. So we will make a shift a little bit into images, basically, for this. And my goal is by the end of the semester, we're going to get to transformers, and then it's going to be text and generative text models, which are, as you will see, they get much more complicated to write from scratch, okay? They get much more complicated. All right, so as usual, I will do this lecture just with WEKA, all right? Because, we're just going to look at what WEKA can do and for classification. If you remember in a previous video, we did WEKA for regression, right? So now I'm going to show you for classification. All right, so video is recording. So we're going to need our WEKA program. We need the data set, which is iris. So this is the famous Fisher's iris data set. So we're going to go to deep learning. So the new things, by the way, actually go back. So just to remind you, on the GitHub where everything is, basics was where we started. Then we just completed regression, right? That's what this was. Deploy to production is whenever we're using Onyx, right? And things like that. And then deep learning is what I'm using right now for this section, okay? So as you can see, we're going to kind of start here with MLP, lead into CNNs, and then we'll start adding other algorithms. So I think I added the iris data set in here. So it's this file, iris.cv is what we're going to need. So you're going to need to download this file onto your desktop, right? And then we're going to launch WEKA, which we have used before, to do the classification analysis. So I'll go over all of that. So let's see. So we won't be using the Jupyter Notebook for this. So I already have Iris CSV on my desktop, all right? But you guys need to download it from the GitHub. Make sense, guys? Okay, so let's go ahead and start WEKA here. So there it is. Okay. Okay, so remember you hit explore, right? So everyone should have this program now on their computers. Please hit Explorer here. Okay. And it's the same similar interface, right? But this time around, it's going to be for classification, right? So it's going to be a few minor differences. So let's start by loading the data set, and then I'll talk a little bit about it. So just click Open, and then go to the desktop. Let me just, this thing doesn't move. Oh, there it is. Down here. All right, so click here and go to the desktop. Okay, and then you're gonna click down here and select CSV. And there's the iris .csv dataset. Okay, so open it. All right, and there's nothing to convert. So now Fisher's iris dataset is very famous, right? It's basically, iris is a type of flower, I believe. And so it's got 4 features and it's got 3 classes. So now we're predicting, given a sample is a plant, is a flower, right? Imagine it's a flower. The features are the descriptors of this flower. So the sepal length, sepal width, petal length, petal width. Okay, those are plant terminology. Yes, please. Yeah, sure. You want me to start all over? Yeah, sure, no problem. Yeah, so you click on open, and then you go to down here. Well, you go to where the file is located, right? So mine is on the desktop. And then you select the data type. So select CSV. Make sense? And then it showed me iris.csv. So I just click on it. Got it? Okay. Then hit open, please. Yeah, and it loads. So I was just describing Fisher's iris dataset. Okay. So Fisher is a famous statistician. There's a paper that he did on this many hundreds of years, like 100 years ago or something. So it's very old. And it's basically about the iris flower. And it's, as I was saying, it's a plant. It's described by the sepal and the petal, and it's the length and the width of it. So really, it just has these 4 descriptors, right, of the flower. And then he grouped the for this data set, he had 3 types of flowers. So basically 3 classes. All right. So what he's doing is the species, I guess, of the flower. And so that's what our model is going to try to predict. So if we click on the features, right, we can look at sepal length. And we can see here the minimum, the maximum, the mean, and the standard deviation. We can do that for sepal width, petal length, petal width, right? And those are the values. Then we can also look at the species itself, and we can see the data distribution. So there are 3 classes of iris, which are setosa, versicolor, and virginica. All right, so WEKA, as you may remember, can take strings, right, in the data set and transform them into numbers. Just remember that when we do this in PyTorch, we're going to have to change to numbers, right? But, for now, we don't have to worry about that. And so there's 50. So this data set only has 150 samples. So that's why it's nice to start with this one, because you can very much picture it and understand what's going on. So X here is what? 150 by 100. Yeah. But the X, the dimensions are 150 by 4. There's 4 features. And then the Y vector is 150 by 1. Yeah? Everyone remember that? Okay, very important. Okay, yeah. So that's kind of it. So now, today, I will also show you about something called feature ranking, which is, how do we know which features are more important than other features? So we'll do that today as well. But, basically what I did before, it was go to this tab, classify, and select several models and test them out. Now, remember that one thing we have to look at is the data type, right? So we're going to look at sepal length. It's numeric. You can see the numeric here, right? Right. Then you can do sepal width, numeric, petal length, numeric, petal width, numeric. That's good. And then here, species, this is where this needs to be different. Before, for regression, this was numeric. But now, for classification, this needs to be nominal. Okay, guys? Now, iris, by default, it detects it to be nominal. But other data sets, this variable could say numeric. Okay? If that happens, you're going to have to go into filters here, choose, click on the filter. Then I think it's unsupervised, right? Then select attribute, I think. And you're going to scroll down and find numeric to nominal. Do you see that? Numeric to nominal, guys? And once you've selected that, you click on the white space of this, and then you need to tell it which feature you want to change from numeric to nominal. So in this case, it would be number 5 because it's species. Got it? Once you've set that up, you click OK and you hit apply, and basically it'll do it. I mean, in our case, it was already nominal, so there's nothing for it to do. Any questions about that? This is important. This is like the one thing that will confuse you with classification. Remember that the variable you're classifying needs to be nominal. Okay, so I'll repeat. You go to filter, and there's many filters in here, okay? Many filters that I won't really cover. You go into filters, unsupervised, attribute, and you select numeric to nominal. And then in the white, you can see it's already selected numeric to nominal. Then in the white space, you want to put in the value of the attribute you're converting. And that's how it changes, okay? And this is so if I give you a homework assignment, you know, or something like that, for instance, like MNIST or one of those data sets, which I probably will. If I ask you to do this in WEKA, or you want to do it in WEKA, you need to check that column for the class is nominal. Got it? All right, perfect. Now you'll know, because if it's not nominal, the classifiers will not be highlighted, so you will not be able to use it. Okay? All right, so let's go ahead and play with, so that's all we're going to do today. I'm going to play with these classifiers, show you how to get values, show you some things about how to measure performance, and the feature ranking also. That we can all do this in WEKA. What you might expect when we meet again in a week is that we're going to be back in the world of PyTorch with our Jupyter notebooks, and we're just going to start building up models. Okay? Any questions? Yeah. So hopefully, I don't know, that might take one set of one day, and then CNN. So that's kind of the, yeah, go ahead, please. You want to change a nominal to numeric, so you must have changed like sepal width, for instance, is what you mean? Is there a nominal to numeric? There is not? No, that's a good question. So nominal to binary, nominal to string. No, I was thinking maybe there's a numeric one, but I don't see it. Numeric transform, maybe. I don't know, honestly. I would just load the data set again. That might be a better solution if you change the variable. But I'm sure, I mean, we could Google it and find out, but I don't know off the top of my head. Yeah. Yeah, just reload it and that should solve it. Yeah. You can Google it. That conversion I usually don't have to do. All right. So let's go ahead and now we know what's important is that species should be nominal. It is. So our classifiers should be highlighted. So let's go to classifiers. And let's take a look. Just hit close here. We're going to do tenfold cross-validation. Remember what that is, right? If we do a percent split, this is equivalent to the train test split where we do like 80% split, right? But we're not using that. Instead, let's just do cross-validation. And with 10 splits, remember what happens here is 10 times you're going to look at the data, but each one of those 10 times you randomize the data and then you split it into 10 bins. Take 9 of those for training and 1 of them for testing. Got it? So that's what we do. That doesn't change. All right. Now, what's going to be important is that here what is the metric that we're going to use? So if you remember in regression, we use what to measure performance? R squared, which is called also the coefficient of determination. That was in regression, but in classification, we don't use R squared anymore. Instead, we're going to use a set of metrics that are all related, which are basically accuracy, precision, recall, the F measure, and the confusion matrix. Okay, so these is the new set of metrics that we're going to use. So I'll have some slides to explain what those are in the next class. But for now, we're just going to be aware that we use a new set of metrics. But at the end of the day, obviously, we want them to be high or something like that. Okay. All right, so let's go ahead and look at the classifier. So you can see similar ones. Trees, we can use those for classification. Okay. Bayes, we're going to have the Bayes solutions now. We have some Bayes classifiers. So if I click on this, you can see I have several here. I will be using naive Bayes, which is actually what I usually consider naive Bayes to be a baseline. One thing about naive Bayes is that it's very fast. So it's usually the first classifier I run because I know it's fast, although it's not the most accurate. So usually accuracy is not great, but at least I know, okay, this is the bottom, and I know it can only go up, okay? But it's definitely very fast. So let's go ahead and check over here that it's predicting species, okay? Right, the only nominal one. And now you can hit start. So you can see it's done. You can see that the output is much faster. In classification, we have accuracy and we have a tendency to want to focus on just accuracy. But as you will learn, accuracy is actually a bad predictor for classification, okay? So you don't want to look at that one. Instead, what you want to look at is this column here, the F measure. The F measure, you can think of it as an adjusted accuracy that is much more accurate, a little bit more accurate. But really, we're going to learn that to interpret our models, we want to look at accuracy, we want to look at precision, we want to look at recall, and we want to look at the F measure. We're also going to have something very nice. We're going to have these metrics for each class. So we're going to know how good it is at predicting if it's setosa, how good it is at predicting if it's versicolor, how good it is at predicting if it's virginity. Does that make sense, guys? Perfect. All right. So these are the metrics. And then we're going to have this thing called the confusion matrix. All right. And that also gives us a lot of very valuable information, right? It tells you, all right, if it's an A, is how many are being classified as A, which is A would be setosa here. It also tells us where they're being misclassified, and that can also be very useful, okay? So all these things are pretty useful. Now, as you can see, IRIS is a very easy data set. This is kind of why I started with it, because it's fast and we can, learn a lot of it really quickly. But it's easy for a machine learning algorithm to do well with it. So here we can see that the overall accuracy is 96%. The overall precision is 96. The overall recall is 96. The overall F measure is 96 out of 100. So that's already pretty good. And, Real data sets are not going to be this, good. Okay, it's going to be much harder, a much harder problem. Got it? Okay. All right. So that's, so this is the output that we're going to do. So if you were doing a homework or if we were doing competition again, right? If I gave you a data set and, another trophy kind of deal, this is what we're going to look at to determine who's the best. Okay. Who gets the best score. So it's got to be the highest, but we're going to do an analysis really and everything and then decide. Okay. All right. So that was naive Bayes. As I said, naive Bayes is a probabilistic type of a machine learning algorithm. We don't have time to cover naive Bayes. I mean, it's a very nice math thingy, but I just, I got to move to CNNs and things like that. So I do have a course, Machine Learning Foundations, a 300 level course, where I usually try to cover some of these algorithms there, the more traditional ones. But in this class, I will not be able to cover naive Bayes. All right, so let's go ahead. So that's one that you should always try because we already know, okay, 96 is the baseline, the bottom, but we can go higher, okay? So now I'm going to take another classifier. I'm going to go to functions. You can see here I have SVM, support vector machines. I have multi-layer perceptron. This is the MLP. This is important because when we do this in PyTorch, we're going to be doing an MLP, right? Just like this one. So it makes sense to select multi-layer perceptron and hit run. So here the neural network achieved 97, right? So it's a little bit higher. So 97 accuracy, 97 precision overall, 97 recall, and 97 F measure. It's interesting to note that if we look at this, it gets almost perfect F measure for Setosa, and then it has a little bit of an error for versicolor and Virginica. And you can see that also reflected in the confusion matrix, where you have two misclassifications here and two misclassifications here. Do you guys see that? What do those words mean? They're the type of flower. Yeah. Yes. So iris, yes, exactly. So those are the classes. So when we do this in PyTorch, this will have to be 0, 1, and 2. And you will have to remember that 0, 1, and 2 mean Setosa, Virginica, and versicolor. But as I said before, WEKA allows you to use strings for the labels. Got it? Yeah. So we have the iris data set means that there's an iris flower. You can Google it. It's like a pretty flower. And then Fisher, Ron Fisher, I think is his name. He did 3 types of iris flower, which are these. Okay. Any other questions? All right. So we did the multi-layer perceptron, and it achieved 97% accuracy. So a little bit better, right? A little bit better. Okay. So let's look at another one. Support vector machines. This is SMO. So you can hit start. 96. So currently neural networks are winning. All right. Neural networks. Right. We're all fans of neural networks, right? So we're happy. Okay. So let's go but let's keep going because WEKA is very useful at giving us information. Okay, so here we have IBK. IBK is the KNN, the K nearest neighbor algorithm. So this one, again, it's one of those that I cover in Machine Learning Foundations, the undergrad class, but I can't. Now I will say this algorithm is very easy to learn how it works. Okay. So click on this one, IBK, click start. Yeah, hit start. 95, so not as good, right? Not as good. Okay, but still good enough. Making sense, guys? We can look at the misclassification here. See, there's more. Now there's 4 and 3. You see that? The confusion matrix is really nice at giving you this type of information. When you're having, when, you know, hopefully I'll find some hard data set for you to, My battery's funny. Give me a second. All right. Sorry about that. Okay, so as I was saying, what was I saying? So K and N gave us 95, and these are the misclassifications 4 and 3 basically. Okay, so K and N is not a neural network based algorithm. I can tell you that. Naive Bayes is not a neural network. They're just different algorithms. One is probabilistic. K and N is based on the vector space model. So, but yeah, we're not going to have time to cover these. I refer you to Machine Learning Foundations, which is a undergrad level class. All right, so let's try another one. Let's go to, I usually never try these, but you can play with those. Don't try these. So really what remains is to try trees, right? Now we learned in regression that random forest was really good. So we want to see here how well it performs, right? So I'm going to start with decision trees, which is this one. It's got a strange name, J48, but that's the decision tree. So hit start. It's got a lot of misclassifications, this one, in the 96% range, right? 96 precision, 96 recall, F measures 96, and accuracy is 96. Do you guys see that? Okay. Now let's try random forest. That was the winner in the regression module this semester. So let's try it. So that should be this one, random forest. Start. 95, so not as good here. So what's the best model? Which one? Multi-layer perceptron, right? So neural networks were better here. All right. So our data, now it's a classification problem, not a regression problem like it was in our tabular data that we did before, the wine quality and all that, right? So now we have, so as I said, you know, Iris is very simple. It's very intuitive to understand, but we're going to start the next set of data sets that we're going to play with are image data sets, and images are much more difficult. So we're going to need the power of neural networks really to find patterns in the images. Okay. And this is where neural networks really shine. A lot of the developments in deep learning were related to images initially, right? So the competition, the ImageNet competition that happened in 2012, really, and everything, all of that was done with related to images, basically. So a lot of big developments happened thanks to image processing. All right, so yeah, so these are the models that that we have available in WEKA that I use. These are the models I usually use for classification. Okay, but there are more, of course. And so we saw, if we look at multi-layer perceptron, that was basically the best. Okay. Any questions, guys? This is how you would do classification with other data sets. So that's kind of the introduction of how to do classification on WEKA. All right, the other thing I'm going to cover is how to do feature ranking. So what is feature ranking? Right, so feature ranking is the idea that if we go back to pre-process here, you want to know which of these 4 features is the most important, right, for the model to be able to achieve good performance, right? Good precision, good recall, good F measure. So it's very useful to know. So what we can do is we can rank them, and there's a lot of techniques to rank them, such as the chi-square, mutual information, information gain. So those are just algorithms from information theory that are applied to the data set to kind of figure out what are the best features. You have those techniques available in sklearn, right, in Torch and everything. But here in WEKA, they're also available and they're very easy to use. So all you have to do is click on Select Attributes here, this tab, okay? And then here, just tell it what you want to do. So I'm going to choose here, and I'm going to just click on Ranker. What that means is I want to rank the features, okay? And if you notice, the pop-up actually says, you must use an evaluation that evaluates single attributes, such as information gain. Do you see that? In order to use the ranker, so yeah, just use that. So just tell it yes. And you notice this has changed to information gain. So basically, it's got these two functions where you tell it on one that you want to rank the features, and then the other one is which algorithm would you like to use. Got it? So I think if I click on choose, ones that I have used in the past, basically information gain. Yeah, just basically that one, I think. I've used the chi-square, but I'm not sure which one of these that one is. All right, so just use information gain, it should be fine. All right, so basically after you've done that, select the class, right? So in this case, species, okay? And tell it to do tenfold cross-validation, just like that, and then hit start. Okay, and there you go. That's it. So based on this output, which one of these would you say is the, let's say you're doing data science, right? And so what would you recommend to your customer here? What's the most important feature? Or let me put it in a more interesting, let me ask you a more interesting question. Which one of these features can you drop without affecting performance too much? Simple width, right? Because it's got the lowest value. So here, average merits, you can see it says 1.03 plus or minus that. 1.3, so these two are very important. Then 0.6 is not as important. And then finally, this one is 0.3. What this means is we can drop sepal width. Sure, but let's just drop one first. Also, it's important because let's say that it takes an hour to measure those 4 features, right? Each of those, an hour. So that would be a lot of money that you have to pay people, botanists, etc., to go do that, right? A lot. So basically, maybe you wanna save money. So you just tell your people that are measuring, okay, out of the 4, just measure petal width, petal length, sepal length, but don't measure sepal width. Because we don't need it, because our model will still be okay without that data. Does that make sense, guys? And we can actually test this. So we know that if we remove sepal width, performance is not going to go down so much, right? So let's try it out. So how do we do that? Let's go to pre-process. You're going to, which one was it? Sepal width. Okay, click on sepal width. You see that there? I selected it. And then you can just click on remove down here. So it's gone now, okay? And now we're going to repeat our experiment, but just with these 3 features. And we want to measure performance. Got it? Everyone with me? All right, so let's go to classify. So now I'm going to start again with naive Bayes. Okay, this is correct. Species, okay. 96, it seems. Okay. So it didn't change, right? Guys? And we can confirm right here, this is what I was looking for. We can confirm right here that it didn't use that feature. You guys see that? It's saying that it only used sepal length, petal length, petal width, right? So Does pretty good. Let's try a few more. Multi-layer perceptron, which performed the best. 97. Okay, good. This one dropped a little. I think that was 97 before. Yep. No, it was not. Okay. All right, let's try a random forest. Actually, KNN may have gone down, so let's try KNN. IBK. 95. No, it didn't. And random forest. Yeah, 95, right? So removing one basically had no effect. Do you see that? So, but it may translate into a big savings in money. So let's try now to remove another one, right? So let's go back to select attributes. And we remove sepal length. So you suggested removing 2, right? So let's remove also sepal length, right? So go back to pre-process, sepal length. So basically you just need the petal is kind of what this is saying, right? All right, so sepal length remove. Okay, we got our 2 features. So now let's go back to classify. And let's repeat the experiment yet again. So let's go to base. 96. Huh? What? It's worse for you? Yeah. If I look at it, I mean, according to this, it's only using 2 features, right? So that's a confirmation. Let's try another one. Let's try multi-layer perceptron. 95. It dropped, right? So this time around, if you look, multi-layer perceptron was in the 97 range. We dropped to 95. Still acceptable for some applications, and maybe it saves you money. So that's the game. Also, another reason why you might want to do this is memory management. Maybe some of the variables are just consuming too much memory on your computer, is too slow, etc. So then this is helpful. Got it, guys? Any questions? Let's go to random forest to complete the exercise. $94. So this one dropped as well. So basically, let's do it one last time. Let's drop petal length. That will have a big impact, I think. But you can see how there's a correlation between petal length and petal width, right? Usually leaves and things tend to be proportional, right? So, but let's remove petal length. It's this one, right? Petal length. Remove it. All right, so now we're going to see a much bigger impact, I assume. So click 90 base. Start 95. Not so bad, actually. Sorry. We can confirm that it's only using 1. Let's try multi-layer. 95. So it's pretty good. Just with 1, it's pretty good. Now this makes sense because, like I said, a flower grows proportional. Okay, let's try. I believe KNN. I have this feeling, so let's try it. 95, still pretty good. And then trees, I think. 94. Yep, 94. So there you go. Anyway, so you've seen an example of how ranking works and feature selection. This is one of the techniques that we can look at that's available in machine learning. We've covered WEKA again, but this time for the classification problem in particular, we looked at the performance metrics. I will have some slides on these next time around, okay? And just be aware, so this kind of concludes the class for today. Just be aware, next week, we are starting PyTorch again, how to code our neural networks, right? So we're going to build, multi-layer perceptron, deep learning, and then CNNs, probably in 2 weeks. All right. As far as homework, I haven't planned anything for homework. So if I do have a homework, it would be, I would let you know next week. All right, let me think about it. All right. Otherwise, that's it for today. And I'll see you guys next Wednesday. Leo, hold on.